All right. So I've already sort of done this question, but I'm going to talk through it anyway. I started doing it and then I got myself muddled up. So we'll talk through this. So in this question, we've got suppose n is the foot of the normal from A to -1 and 3 to the plane x, y, 2z equals 27. Find the coordinates of n and hence find the shortest distance from A to the plane. Okay, so the idea being here, we've got this point out here, A, and it goes directly to the plane. Okay, and because this is the foot of a perpendicular, it means everything from the plane is perpendicular. So it goes directly out, and from our equation of our Cartesian equation of a plane, which we've got here, so this represents our plane here, we can get the normal of this straight out the bat. Now, from that, what we're going to look at here is we've got a fixed point, and then we've got the direction vector is going to be the normal of the plane, which we can get. So using this, our position vector of this n value is going to be given by our fixed point, which is up here, plus our direction vector of our perpendicular, of our plane. So from that, this is written in the vector form. I've done the parametric equation. So we've got our x, we've got our y, we've got our z. Now, just like our previous question, we can sub them into the equation of the plane. So if we look at the equation of the plane, we've got x minus 1. So the coefficient of x is 1, minus 1 in front of the y, and then 2. We've got 1, -1, and 2 here. So we sub that in. We can then solve this for lambda, which we do, and that gives us our coordinate of n. So now we've got this fixed point. We've got this n value of n is -4 and 9. So I'll now draw this on my diagram. I'll pick like a green there. So 5, -4, and 9. So 5, -4, and 9. And so now the question gives us our hence part. Find the shortest distance from A to the plane. Now, the idea being that if we can figure out what A to n is, then we just find the length of it. So what we do is we can go, well, the distance of A to n is going to be given by the square root, and then our x coordinate is going to be 5. So I'm going to use the n value first. So 5, I'm just going to go squared plus -4 squared, and then plus our final value here is 9, and that'll be squared. So I've just got the values from n. Now I need the values from A. So you got to remember that we're going to subtract them all. That's how we figure out the difference between the values. So I'm sort of cutting corners here. 2, -1, and 3. So we're going to go 2, -1, and 3. And these values here are going to give us square root. 5 take 2 is going to be 3 squared. And then -4 plus 1 is going to be plus -3 squared. So we've got 2 9s there. And then this last one is going to be 6 squared, which is going to be square root 9 plus 9, which is going to be 18 plus 36. Okay, which means 18 is going to give us 44 plus 10, so 50 square root 54 units. Now,